Welcome. This video briefly reviews some ways to use arrays. So the first thing to mention is that C++ and C arrays are a very low-level construct. In most programming languages, an array is much nicer to use. And in C++ at least, we will learn about nicer tools for representing, say, a list of things. Ones where we don't have to worry about bounds checking, about by accident walking off the end. Ones where we don't need to worry about keeping track of the size manually and knowing it at compile time. Ones where we can resize on the fly or insert or delete things. But all of those fancier tools are going to be built from these basic arrays, so we do have to understand how they work. So the most straightforward way to use an array is as a list. It's a very low-level primitive way of doing it, but if I want to represent 8 scores, I can have an array that does that. And that is going to be easier to use than 8 separate variables because I can loop through an array and do something to each score as opposed to having to copy and paste chunks of code around to handle 8 different variables. Another use is as a lookup table. So say I want to represent the days of the week, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. I could put those strings in an array and very quickly, if in my program I'm representing the days of the week as numbers, use that array to look up the name. If I want to print out the day, what day 0 is, I could use this array to print out Sunday. And that's the strategy we see in the book problem on the deck of cards, where we have an array for the suits, which suit names they are, an array for the ranks, ace, 2, 3, 4, etc. And we're actually representing playing cards as numbers, and when we need to look up something like what suit a card is, we just calculate what suit that number happens to be and get a number 0, 1, 2, or 3 and use that to index into this array to find the right name for the thing. A little bit more efficient than having a big if-else where we say, well, if it's 0, print clubs. If it's 1, print diamonds. The third kind of major strategy is as counters or flags. And we see this in the book Lotto Problem, where we're trying to make sure that we have every possible lotto number. Not every possible combination of them, but just every number in the lottery we've got at least on one ticket. And so there's a big array that starts with a bunch of falses, and as we generate a particular number, we change that number to be true to indicate that we've got a copy of that. And then we can go through the array and decide if everything in the array is true, we know we've got every number covered. We could also use this for problems like counting how many people got A, B, C, D, or F on a test, how many times we've rolled a particular combination with dice, the number of times each letter appears in a given file, all kinds of possibilities. So for the test example, rather than having variables for A, B, C, D, and F, I could have an array with 5 elements, initialize it all to 0, and then come up with some scheme like 0 is going to represent the F's, index 1 is going to be the D's, index 2 is going to be the C's, and as I go through my list of scores, increment the appropriate counter. So I see a 62, I figure out that that's a D, I increment that counter by 1. And I see 84, I increment the B counter. See 71, increment the C counter. See an 89, increment the B counter again. And so I'm just keeping track of a running total of how many of each grade I've seen. So what this might look like is I've got some array of scores, which we don't see here, but I look at each score, I grab the current score, score sub I, and just store that as current score, compare it to the thresholds that I'm using for my various grades, and then increment the appropriate counter. And then when I'm done, I've got the total number of each grade. Now this is maybe only slightly better than individual variables because I do have to kind of still have the if-else's, and I'm using them separately here. But we can see the advantage of this approach with a problem like rolling 2 dice. When I roll 2 dice, I can get a number between 2 and 12 if I add the 2 dice together. So 11 possibilities. So I could store that in either 11 different variables or an array with 11 slots. Now, if I do it just like this, so if my array goes from 0 to 10, I'm always going to have to do math. And so like if I want to, hey, I rolled a 6, I need to update that counter, I'd have to like subtract 2 to come up with the right index. So an alternative would be I'm going to make my array have 13 things and just ignore the first 2. And that way I'll index in, if I roll a 2, I'll directly index into element 2, and I'll just pretend those don't exist, so that I don't have to do this math to convert from what I rolled to what slot is representing that. So how this might look in code? Well, I make an array with 13 slots, initialize everything to 0. 1,000 times I'm going to roll some dice, and I've got a function. We don't have to worry about exactly how that works. That's going to roll however many dice I'm rolling, in this case 2, and it can give me back a number between 2 and 12. That'll be the roll. I can use that value to index directly into my array. So if I roll an 8, I want to increment the 8th counter by 1. If I roll a 12, I'm going to increment element at index 12 by 1. So I don't even need an if-else, right? Whatever number I'm working with, I can use to index directly into that array and skip all the if-else that would be involved with a bunch of different variables.